Tim is also a developer advocate at mLab. His developer weapons of choice are Node, Python, and React. And in his free time, he, I think fairly recently, started to also be an open source contributor to Kubernetes. And Kubernetes is what he's here to talk to you all about tonight. So let's give Tim a round of applause.
Hey everybody, I'm really excited to be able to talk to you about Kubernetes today. So this is going to be just an introduction to Kubernetes, which means you don't need any prior knowledge of Kubernetes before going through this workshop. It might be useful to have a little bit of an intuition about containers, but you should be fine without that. If you do need to brush up on containers after this workshop, then Naomi gave a presentation on Docker and containers at the last meetup, and you can see the video for that on the meetup page. So for this workshop, we're going to learn what Kubernetes is in the first place. We're going to start to kind of understand some of the components that make up a Kubernetes cluster. We're going to go through some practical examples too, where we're going to deploy our first applications using Kubernetes. And we're going to be exploring the kubectl command line tool, which is the command line tool that we use to communicate to Kubernetes clusters. So first of all, what actually is Kubernetes? Well, it's an open source system for deploying, scaling, and managing your applications. Kubernetes sounds like a little bit of a weird word. It's actually the Greek word for helmsman or pilot, and that's why the logo is a ship's wheel. And it's the root of the words governor and cybernetic. It's a bit of a long word, so oftentimes we'll just shorten it to Kates. And in fact, our little smoothie mascot is called Kate in honor of Kubernetes. So now you know our mascot's name. So the predecessor to Kubernetes is a system called Borg, named after the Star Trek scary robot people. And Borg is Google's internal cluster orchestration system, which they've been building on and improving on since 2003. So Google obviously know a thing or two about deploying applications at large scale. So they brought all that knowledge they had from building this Borg system, and they made Kubernetes, which is kind of an open source version of Borg. And they open sourced that in 2014. It got immediately a lot of traction. It was really popular. And in 2015, they donated it to the Cloud Native Computing Foundation, which is a part of the Linux Foundation. And Kubernetes grew in popularity again and again, and it's running a lot of the applications that we all use on a day-to-day basis. How many people here have played Pokemon Go? Yeah, a lot. Pretty cool. So Pokemon Go was launched in 2016, and it's actually run on Kubernetes. They had to deal with like 50 times the amount of traffic they were expecting in the first kind of launch, and it's definitely a little bit bumpy at the start, but they managed to scale it relatively well. And kind of the popularity of Kubernetes has been growing and growing over the past few years. This year, about 40% of enterprise companies are running Kubernetes clusters in production. So it's a really important part of the technical stack to start to get to learn and to become familiar with. So what does Kubernetes actually do? Well, the core thing of Kubernetes is a Kubernetes cluster, which is a group of machines which are all running Kubernetes. And developers will define kind of how they want their application to be run in a YAML file. So they say, hey, I want to run this container, I want to expose this port, and I want to run it with this amount of memory. And this is a declarative file that is kind of describing the desired state of the application. And this is kind of opposed to an imperative style, where you say, hey, first I want to install this, and then I want to install this, and then I want to run this and this and this, where what you end up with from the file, you don't really know what that looks like necessarily, because you have to run the file to be able to see what comes out the other side. So imperative kind of style defines actions, declarative style defines state. And this means that declarative styles are a lot more readable, because you can just look at them and say, oh yeah, it's running that container on that port with that much memory. Easy. So they send this file to a Kubernetes cluster, and the Kubernetes cluster will kind of take a look at what needs to be run, and it will bring up that application. Specifically, bring up a container running that application. And the containers running Kubernetes are meant to be immutable. So that means that you don't shell into it and start running commands. So if you want to upgrade it, you don't kind of shell in and say sudo apt-get upgrade or anything like that. You just tear down the old container and you have a new configuration file that defines the new version. You send that to Kubernetes and it will bring up the new container for you. And this simplifies things a lot because you make sure that the applications that you're running in your actual cluster exactly match the configuration that you have in your files. And that makes kind of doing operations a lot easier. So I said that Kubernetes brings up a container. Actually, it brings up the application container inside of a wrapper, which is called a pod. So pods are the basic unit of deployment in Kubernetes. And it's just a wrapper around one or more containers. And containers inside of a pod, they share a bunch of resources like storage and a unique IP address. Now, sometimes you'll want more than one container inside of a pod, but more often than not, you can just think of a pod as a wrapper around a single container, because you'll usually just be deploying a single container inside of a pod. So that's kind of like one of the key pieces of jargon that you need to learn for working with Kubernetes, is that you deploy pods. And when you have your pod deployed, it's actually really easy to scale. It's very easy to scale up and down because remember that definition that we had before? Well, instead of saying, hey, run me one version of this, you just say in the definition, I want 3 versions of this. And you send that to the Kubernetes cluster, and Kubernetes will take care of making sure that 3 versions will always be running. Kubernetes is also very clever about how it runs these pods. So it will schedule the pods in the most efficient way based on the resources that those pods need. That allows you to pack as many containers into your cluster as possible and get the most out of your machines. Now, once you have things running inside of your Kubernetes cluster, one of the core concepts of Kubernetes is its reconciliation loop. Kubernetes knows what state you want your application to be in because you declaratively defined the state of the system and what it should look like with your configuration files. And that's the desired state of the system. It knows what you want. So it constantly looks at what's actually running in the container. That's the current state of the world. And if anything is out of sync, it will take actions to make sure that the current state exactly matches your desired state. And what this means for you is that Kubernetes is self-healing. If you told Kubernetes to run 3 pods of container A, and suddenly a pod goes down for some reason, Kubernetes will see that there's only 2 pods, and it needs to be running 3. So we'll say, oh no, I've only got 2, I need to be running 3, I'll bring up another one. And likewise, if a pod reappeared suddenly, and there were 4 pods, and it was only meant to have 3, it would say, oh no, I've got 4, and I'm meant to be running 3, so I'll just take one down. So it's constantly working for you to make sure that your system is running as you have told it to be running, as you have defined. So these are some of the things that make Kubernetes really great. First thing is that declarative configuration, that you're able to define the state that you want your application to be run in, the state of your system. And that's really great because you get to keep that in version control, and it's very easy to manage, oh hey, we made a change to the system. Rolling back is really easy. You just go back to the previous version of your definition. And it's really easy to scale. There's a lot of things you can do around scaling. You can do some clever auto-scaling stuff if you give it a range of between 2 and 10 pods. And it will maximize capacity for you in an intelligent way. And of course, the self-healing thing is fantastic. If a pod goes down on Friday afternoon, right as you're about to go home, then it's not your problem. Kubernetes will have already detected it and brought it back up before you'd even realize that anything is wrong. So Kubernetes is made up of several different components, and it's useful to understand what these components are and what they do. And each component is its own binary that needs to be run on a node inside of your cluster. So when we take a look at a Kubernetes cluster, As we said before, it's made up of lots of machines or nodes. And we have several master nodes, and the job of these master nodes is to kind of just manage the whole cluster and make sure everything is running smoothly. And then you have worker nodes, and these are the nodes where the application containers are actually run. So let's take a look at some of the components that are on one of these master nodes. The first thing is the Kube API server. And this Kubernetes API is the core of Kubernetes. Other components talk to each other through this API. And it's just a JSON API that you can send requests to directly, but more often than not, you'll be using a command line tool called kubectl to talk to your Kubernetes cluster. So you have an API server, and the API server needs to store state about your cluster, needs to store some information. So it needs a database. And Kubernetes uses a database called etcd, which is a distributed key value store. Sometimes this is put on its own nodes, separate from the master nodes, but oftentimes it can be on the same node as the master as well. Next, you have a component called kubescheduler. And this is the component that watches for containers that haven't been assigned to run on a node and selects a node for them to run on. A scheduler has to take a lot of factors into account to decide where to run its pods, such as resource requirements, hardware constraints, and any user-defined specifications. And this is the part of the system that makes you able to maximize capacity and will pack those pods in as efficiently as possible. Next up, you have the controller manager. And these are the core control loops of Kubernetes. These are the things which are running those reconciliation loops. They're always looking at the state and trying to move it to the desired state of the system. And it observes and acts on the cluster through the Kubernetes API. Finally, Kubernetes requires a DNS service to allow for service discovery. And this has to be somewhere in the cluster. Oftentimes, you'll find it on the master node. So those are the master components. But there are also components which run on every node, both the masters and the workers. So let's take a look at one of the workers. Here, the first thing is something called the kubelet, which is the primary agent that runs on each node. And it takes a list of pod specifications from the Kubernetes API and ensures that the containers described in there are running on the node. And in order to run those containers, it needs a container runtime. So kind of the most famous container runtime is Docker, but you can use other things like the underlying Docker technologies like runc, or you can use Rocket or any other kind of OCI-compliant container runtime. And then finally, you've got kubeproxy, which is a network proxy which will run on each node and allows for service discovery in Kubernetes. So as I mentioned, these are actually on every node. So if you look at all the components on a master node, these are all the components that are there. Now, that's a lot of components in order to build up a Kubernetes cluster, right? And it might sound like a lot and be kind of overwhelming right now. It's totally fine. Just to give you kind of a brief overview of, if you hear this word, you roughly know where it fits into place. One of the nice things about this is that all of these components are highly configurable. So you can make a very customized solution to your requirements. It's also very extensible. So you can add more components to your cluster. If you want to have a component that runs monitoring, you can add that in. If you want a component that runs logging, you can have that. Kubernetes clusters often, they have very specific guidelines for how networking should be set up. So oftentimes you'll see some sort of networking component that kind of manages an overlay network. And you can also extend some of these. So you can add your own controllers to be kind of managed by the controller manager, your own kind of little control loops. You can add your own objects to the API, your own endpoints to the API. So it's very extensible and very configurable. And that's great for kind of the power of the system, but I'm sure you can already see, this is kind of pretty complicated. And when it comes to setting up your own cluster, it's really hard to set this up. You can already see, having to put all of those on the nodes and making sure that they talk through each other through SSL is very hard to do manually. So a much easier way is to use tools that kind of make this a little bit more automated for you. Some tools that you might want to check out are kops, kubeadmin, or kubespray. These help you set up a Kubernetes cluster. This still can be kind of tough to work with, though, sometimes. The easiest way is probably to use a managed Kubernetes service. Google, AWS, and Azure all have managed Kubernetes services where you just click a button and it will bring up all the nodes for you. They manage the configuration and make sure it's all done correctly. And then you can just talk to it through the command line, which is much easier. If you did want to run a Kubernetes cluster on your laptop, there's a piece of software called Minikube, which lets you do that. It'll set up a single node cluster on your laptop and kind of make it make something that you can play around with. But for right now, we're going to get into some practical stuff. And in order to do that, we've got a little sandbox on Katacoda. So if you go to this link, which is bit.ly/smooth-kates, then you can check out our little Katacoda sandbox. If you don't have a laptop or if you're not feeling like typing or anything, just you can feel free to watch, or you can group up with somebody else. You'll need to sign up for Katacoda in order to kind of get access to it. So it's bit.ly/smooth-kates. Okay, I'm going to head over there myself. Oh, I have one of the touch bar things, and I don't know how to get it to mirror screens on the touch bar. Does anybody know? Okay, let me go to display settings then. I have to do it the... Used to be you had function keys. Okay, there we go. Great, let me make sure this is still working. Nope, I need to refresh. Okay, is everybody who wants to be on this website on this website? Does anybody need to know the link again? Okay, cool. And can everybody see the text on the screen okay? Or should this be magnified? The back, yeah? It's all good? Great. Okay. So this is a little website called Katacoda, where you can kind of spin up machines and have little sandboxes to play around with. It's really cool. Recommend checking it out. They've got other tutorials on Kubernetes if you want to learn more after this. So right here, we've got two machines. We've got one at the top and one at the bottom. The top one is our master node, and the bottom one is our worker node. So we've got a two-machine cluster here. And these machines have Kubernetes running on them, and they also have the kubectl tool, which is the command line tool that you use to communicate with the Kubernetes cluster. So to start with, I'm going to run kubectl get nodes. And the way kubectl works is you have kubectl, and then generally you have a verb like get or describe or create. And then you have a resource name. And then after that, sometimes you'll have like a specific name. So here we're just listing all of the nodes in the cluster. And we'll see what we already know. Excellent. We've got a master node, and we've got a worker node. So this one's got role master, and this one is just none, because it's not very special. So that's fantastic. We can also take a look at the health of the cluster. So on the side here, I'm just going to click to run kubectl get component status. And here we see listed out some of the components that we talked about before. We've got a scheduler, and that's running. We've got the controller manager, and that's running. And we've got etcd, which is the database, and that's running. So that's fantastic. Now let's see if there are any pods running. So we run kubectl get pods. It says no resources found. Well, okay, there's no surprise there. We didn't tell it to run any pods yet. Actually, Kubernetes is running a couple of pods in the background. Kubernetes can be split up into, a cluster can be split up into different namespaces. So if you've got a really large cluster and you've got multiple teams in your company kind of using the same cluster, you can split it up into different namespaces. And one team can be using the front end namespace and do all their front end stuff. Or there's maybe a data science team and they're using a different namespace called data science. And then all of their pods aren't going to like clash with each other if they have got the same name. And there's an internal namespace called kubesystem, which is kind of for all the under the hood stuff that Kubernetes is running. So actually, if we run kubectl get pods, and we ask for the kubesystem namespace by doing -n kubesystem, we can also change the output format of our commands. Here I do -o for output, and I say wide. That gives us a little bit more information about in the table view. Then we see, oh wow, there's actually a lot of pods running here. I think we're cut off slightly. Okay, so we see that there's a pod running for etcd. There's a pod running for the API server. That's a pod for the controller manager. We see that kubedns is running. We see that there's a kubeproxy running on the worker node, and there's a kubeproxy running on the master node. Remember, that was one of the things that runs on both nodes. Yeah. Yeah, it's literally called a default namespace. So the question was, is there a default namespace? And there is, yeah. So you don't have to specify the namespace ever. So this is kind of just to show you a little bit about what it looks like when you're looking at running pods. You've got the name of the pod. The ready column shows how many containers in the pod are up and running. You've got a status, which luckily everything here is running. Restarts, we see a couple of pods actually had to restart. So maybe there was some sort of intermittent problem there and they had to kick off the start again. There's IP address for each pod. And then it tells you what node it's on. So one of the cool things here about Kubernetes is that it's actually running a lot of its components inside of its own pods. It's managing its own components itself. I think that's pretty cool, like when a system can kind of monitor its own health and make sure that it's running correctly. Cool, so that's kind of like a list of pods. Does anybody have any questions about that so far? Oh, yep. Sorry, I didn't catch that. Yes, you can check all namespaces. So if you're new to a cluster and you want to see, hey, what's everything that's running in here? Luckily, oh no, my, for some reason I can't, oh, there we go. Control C. Okay. I'm going to actually move this out of, I'm in presentation mode, so I can't see the actual, it's like overflowing. And maybe if I, oh no, this is really awkward. Clear, okay. Sorry, the command line is getting a bit messed up. So if you want to see everything that's in all namespaces, you can do kubectl, and then some command like get pods, and you just do -- all namespaces. And it's showing us the namespace as well. So if we had something in different namespaces, then we'd be able to see everything. But everything right now is just running in kubesystem, because we haven't run anything ourselves. And if you wanted to actually see the namespaces, like kubectl is very intuitive. So if you wanted to see what the namespaces are, what do you think we'd run? Probably kubectl get namespaces. And we see they've got the default namespace. The namespace is called kubepublic and kubesystem. Okay, cool. So let's start by deploying our own pod then. So generally, we define your specification in a YAML file. So let's take a look at pod.yaml. So I'm going to run cat pod.yaml. So this is the file here. So the type of the resource that you're creating is defined by the API version and the kind. So you've got v1 pod. So we're going to be creating a pod. Then you can add a bunch of metadata about your resource. Here we've added a name and we've called our pod DevOps. And then you've got a specification. And this is the section where you specify the containers that you want to run, specify any kind of volumes that you want to run, or other things. So the container here that we're running is tfogo/devops v1. So it's going to take the tfogo DevOps image from Docker Hub. And that's just an Nginx image, which I've kind of altered to serve a little bit of text. And it's going to be serving on port 8080. So we tell it, hey, I want to expose port 8080. So this pod, I'm able to actually get at port 8080. Cool. Now, in order to create or update any resource, you just need to know one command. It's kubectl apply. And then you do -f for file name, and you pass it the YAML file that you want to send to the API server. So let's run kubectl apply -f pod.yaml. And it says pod DevOps created. Great. So that manifest has been sent to the API server, and it's kind of parsed through it and said, okay, I'm going to send that to kubescheduler, and we'll schedule that pod on a node, and then that will be sent to the kubelet on that node, and kubelet will run it in the container runtime. Yeah. Yes, so this metadata name is the name of the pod, and this is the name of the container. Because remember that we can have multiple containers inside of a pod. For example, the kubeproxy pod has 3 containers in it, and they all are called different things. So let's run kubectl get pods and see what we get now. We see, great, we've got a pod called DevOps. It's got 1 container out of 1 containers running, and that's exactly what we wanted. You can see more detailed information about a resource by running kubectl describe. So I'm going to say kubectl describe pod, and then the name of the pod, so DevOps. So here it gives a little bit of information about the system. It says the node that it's scheduled on. So this is scheduled on the worker node. It says the pod IP. That's the unique IP that our pod has. I'm going to just copy that because I want to use that. It says the port that's running on. It gives you like a little bit more information, and also gives information about like the events that happened in the pod's lifetime. So it started off, it got scheduled, which was the scheduler, and then the kubelet took over and pulled the images down and ran it. You can also kind of get the IP address really easily by running kubectl get pod DevOps -o wide, and -o wide will include the IP address in there. So let's see what we get when we curl that IP address at port 8080. So I'm just going to copy this IP address, go to port 8080. And it's smooth DevOps, yay! You gotta cheer. Thank you. Cool. So that's deploying our very first pod. And it's now time for a smoothie break. I was chatting to some people over the break, and we just deployed our first pod. I think one thing that's important to talk about is containers in pods. As I said, you generally want to have like one container per pod. You definitely wouldn't have like multiple of the same containers inside of a pod. You just have multiple pods. And you only want to have multiple containers inside of a pod when they're very tightly coupled, like when they're kind of meant to be run together. If they could be run separately on different nodes, then just put them in separate pods. So in general, like most use cases, you want to just have like one container per pod. It's just a little bit about kind of the thought processes behind how pods work. So we've made our first pod. Now let's look a little bit into the different kind of different ways you can configure your pods. So the first thing is you're able to let Kubernetes know how much RAM and CPU you want your pod to have. So you're able to make a request, and you're also able to make limits to say, hey, this pod should not go over this amount of RAM and CPU. If it's going over that amount, something's gone wrong. Like let's not let it go too crazy and take up all the resources on the machine. So in order to do that, let's take a look at the pod with resources YAML file. That's pod-with-resources.yaml. Just going to do cat pod with resources.yml. And this is the file that we get. So it's very similar to the last one we had. We have a new name. This one, pod, is going to be called DevOps with resources. And it has a single container inside of it again. This container name is just DevOps, so different. Again, container port, we're exposing port 8080. And now there's a new field, resources. And under this, we've got kind of two new sections. We've got a request section where we say, hey, we want at least half a CPU. And we want at least 128 megabytes of memory. And we've got limits. We say, but don't go over one CPU core and don't go over 256 megs of memory. Cool. And then when we schedule this, we do this with kubectl apply again. So we do kubectl apply -f, and we give it the file name pod with resources.yaml, and it'll create a new pod for us. So if we do kubectl get pods, I'm just going to type that out. We see that we have the DevOps pod that we made before. If you had to restart, or you're starting fresh, then you won't have that DevOps pod, but you should see the new one, which is DevOps with resources. And the scheduler will have taken that pod and will have looked at the limits, and will say, hey, I need to put this on a node where there's at least this much free. So it's kind of used those limits to its advantage in scheduling. And if we describe this resource, then we can see it's got kind of a limits section and request section right here. Cool, and I'm going to clean out the pods when we're done with them, just so we don't get all cluttered. In order to delete resources in Kubernetes, it's very simple. It's kubectl delete. So you just do kubectl delete pod and then the name of the pod that you want to delete. So here I'm going to run kubectl delete pod DevOps with resources. And if I run kubectl get pods again, it's gone. Great. One of the kind of really neat things that we should have noticed whilst kind of applying these definitions, sort of running these pods and taking them down, is it's really quick to spin them up and take them down, which is a really nice thing about containers in general, is that they're very quick to start and very quick to take down. And it makes things like rolling updates nice and snappy. So Next thing that we're going to add to one of our pods is a liveness probe. So we mentioned before how Kubernetes watches pods to check if they're running or not. And you can define exactly how Kubernetes determines if a pod is healthy or not by setting a liveness probe. So that Kubernetes can be kind of intelligent about knowing how your pod is healthy or not. You can kind of give it a little bit of that internal knowledge that it might need about your application. So let's take a look at pod with liveness.yaml. Cat pod with liveness.yaml. And we'll see, again, really similar pod definition. We've got a new name, DevOps with liveness. We've got the same container specification. We've got the same image. It's running on port 8080. We've got a new section here called liveness probe. And the probe that we've set up is an HTTP GET request. And it's going to be checking out the health Z route on port 8080. And it's got a bunch of kind of extra information about how long it should wait before testing for the first time, about how long it should wait or let the kind of response time out, how often it should be doing this check, and how many failures it will see before it says, okay, this is definitely dead. So if we apply this pod specification, then this pod is going to come up. We see DevOps with liveness. We see this at this IP address. Let's actually check out and see what's at that health Z path. So if we curl at this IP address, this DevOps with liveness pod, port 8080/health Z. You see, it just gives us back a 200 OK. And that will tell Kubernetes, yes, this is alive. So we've got a liveness probe. There's also a concept of a readiness probe. So the liveness probe tells you, yeah, this pod is alive and it's actually running. That's great. But it doesn't necessarily tell us, hey, is it ready to send traffic to yet? Like, can I start sending it HTTP requests and that kind of thing? So that's where a readiness probe comes in, where maybe you've got a pod which, when it starts up for the first time, it needs to do some initial setup, which might take some time. Maybe it needs to like register with some external services or something, and that's going to take up a bit of time to make sure it's ready. So you can set up a readiness probe where, you have an endpoint, say, that will start giving 200 OKs as soon as it's actually ready to receive traffic. So again, it's another way to make your applications a little more intelligent about whether they're healthy and whether they're ready to serve traffic or not. Yeah? Just if the pod is running, like if the process is running. Yeah, and then I think the readiness, it just says if it's running, it's ready. So it just kind of assumes the base case. Sorry, and that was like if it doesn't have a liveness probe, like what does it do? Is the question. Yeah, and this is really useful for things like load balancers, because load balancers, they need to know when like services are ready to send traffic to. Okay, so we've got 2 pods so far. That's a lot of pods. I'm finding it really difficult to keep track of my pods. Maybe 2 is not too difficult for you. Maybe when you get to like 1,000 pods or 10,000 pods, you're starting to find it's really difficult to keep track of things. Well, luckily enough, we've got something called labels and annotations to help you keep track of the information about your pods. So when you've got a lot of pods, you want a way to be able to organize and sort and identify them. So Kubernetes allows you to add labels to your resources. So you can add labels to pods, but you can also add labels to a bunch of other different resources. Labels are just key value pairs that are used to identify resources. So they can be things like a version number, they can be things like an environment, or like the application tier, like whether it's front end or back end. And they're used by some resources to match to and point to other resources. So for example, we'll see in a bit a resource called the service, which you can think of kind of like a load balancer. And it's going to point to a group of pods. And the way we say point to this group of pods is by saying, hey, we've got this label on these pods. I want you to match all the pods that have this label. So labels are used for kind of selecting things and pointing to things. Annotations are also key value pairs, but they're kind of meant for non-identifying information. They're just a place to store additional metadata about a resource. And they can be used by Kubernetes internally or by other third-party tools in order to store information about resources. It's kind of like just a bucket that you want to put things in to store information. You shouldn't use it as like a database or anything. That's what etcd is for, but it's useful to kind of append information to resources. I think getting started, like labels and annotations, is like, what the hell is the difference between them? They're both key value pairs that are attached to a resource. Just think of labels are selectors, and annotation is just any other information you might want. So let's take a look at the pod with labels.yaml file. Cool, so we've got a pod again. We've got a new name, DevOps with labels. We've got a new section in metadata. So besides the name, we now have a label. So whereas names are unique, labels do not necessarily have to be unique. Multiple pods can have the same label. And here we've got a label of end prod and app DevOps. So it says what the environment is and what the app is. And these aren't special names either. These are just names that we've given. So they're meaningful to us as administrators of the cluster. And then we've got an annotations section. And here I've just added some Git info. I've added the latest commit to this code base, or last commit that the container was built from, something like that. And maybe this is being used by some sort of third-party CI/CD pipeline to keep track of things. Maybe it's being used for like presentation in a dashboard so that you can see like pretty names for things. Or maybe I just put it there for my own information. Cool, and then we've got the container spec that we saw previously. So nothing kind of new there. So let's apply this pod spec. So we see DevOps with labels was created. That's great. And now we can use kubectl get pods -- show labels, which is a useful way of seeing our resources with the labels in the table as well. So we're going to run kubectl get pods -- show labels. Great, you can see the ones that we made before, DevOps and DevOps with liveness, they have no labels. But our new one is app equals DevOps and env equals prod. And this is great because it means that we're able to, if we have multiple pods with like app equals DevOps, then we can kind of group all these pods together and select them. Cool, so now you know how to deploy single pods. But in the real world, we don't want to deploy a single pod. We want kind of a distributed application which is running multiple versions of the same container. And we want to be able to do it in such a way that we can scale and update them really, really easily. And deployments is how this is done in Kubernetes. So on the worker node, I'm going to run a command to watch the pod. Oh, no, I'm not. That's disappointing. Okay, unfortunately, my master didn't time out, but it looks like my worker timed out or something, so I can't run that. Let me just restart. I'll restart. I'll just speed through to the end. This is the benefit of cleaning up all the other pods for me as well, so they won't get in the way. Great, so every 2 seconds I'm just doing a kubectl get pods, so there's no resources yet because I want a fresh deployment. And let's take a look at a deployment object. So you'll see here we've got a new type of object. It's no longer v1 pod. We've got an API version of apps v1, and the kind is deployment. We've got some metadata about this again. We've called it DevOps. This is the name of the deployment. And we've also added a label to it. And we've got a specification. And this specification is a little bit different from the standard pod specification. So we have replicas. We can set how many pods that we want to actually deploy. We've also got a selector. And we say, hey, we want to match these labels. So now any pod that has the label app DevOps will be sucked into this deployment and will say, that belongs to me. That's one of the pods that I'm managing. So you can already have pods that are spun up with a label app DevOps, and you can just have a deployment on top of it. And you can deploy a deployment on top of that. And then we have a template for the pods. So here is kind of our standard pod language, where we've got a label. It's important that this kind of matches the label that tells it's part of the deployment. And we've got the spec that we're used to, tfogo DevOps v1 on port 8080. So let's apply this deployment, and we should see 3 pods be spun up. Deployment DevOps is created. It's creating containers. You see we've got 3 lines here. We've got one is running now, second one is running, and they're all running. Great. And you notice that deployment gives the name of the pod, and it appends this kind of alphanumeric string to make it unique. And they're all running on the worker node. And they've all got unique IPs. So that's pretty cool. It's really easy to scale deployments up and down. So I'm just going to edit this deployment.yaml file real quick. I'm going to say, hey, I want 5 replicas. I'm going to save that. I'm going to apply that again. And we see 2 new pods immediately spin up. It's pretty cool. Now, when we make changes to the pods themselves in the deployment is going to perform a rolling update of its pods. And deployments allow you to set exactly how that rolling update happens. For example, you can tell it to only replace 1 pod at a time if you want to take it really slowly. You can tell it to bring up a whole new set of pods before you take the other one down, in which case it's kind of like a blue-green deployment. So let's kind of update the version of the container we're deploying. So we were running tfogo DevOps v1. Let's run, let's apply deployment-v2.yaml, which will set it to be tfogo DevOps v2. And you can take a look at the status of the deployment here by running this command, kubectl rollout status deployment DevOps. Great, you can see it's terminating some containers. So these ones are old ones, and it's bringing up the new ones. Pretty cool. What I'm actually going to do is I'm going to watch, kubectl. Deployment, DevOps. Kubectl get deployment. I said debt, did I? I did say debt. Debt is not a word. Cool, and it kind of shows you, hey, you want this number of containers. These are the current number of containers that are running. These are how many are up to date. And if you kind of roll something out, then you'll see these numbers changing as they're spinning down some containers and bringing up new ones. You can look at the history of a rollout by running kubectl rollout history deployment and then the name of the deployment. So you can see here the very first revision, revision 1, it was the initial one. There's no change cause there. And you'll see version 2, there's a change cause. I said update to image v2. And here's actually an example of where annotations are being used. So if we run cat deployment v2.yaml, you see that inside the metadata for the pod spec, I use an annotation, kubernetes.io/change calls. And when I set that, that will be set as, Kubernetes will pull that in as the change calls in the history. And if you ever want to roll back history, say we want to kind of undo the terrible mistake we just did, we can run kubectl rollout undo, and we can use --2 revision to go back to like a specific point in history if we need to go back really far. So I'm going to run that. And we see that currently there's 4 containers. You see the numbers changing. It looks like that happened pretty fast, and they're all up to date now. But if you have like a large number, you can kind of see them going up and down. It's kind of cool. Cool, so now we've got all of our pods deployed horizontally. We've got lots of them running. That's great. But the final thing that we need to piece this all together is we need some way to actually address these pods. And that's where a service comes in. So when you are doing a deployment, if you're taking down pods and you're bringing them back up again, they might be coming back up with a different IP address. So you don't necessarily know like what IP address your pods are running on. And on top of that, if you want to load balance between them in some kind of intelligent way, then you need something in front of those pods in order to like address that service as a whole. So because the pod IPs can change, we have the service object, which is a layer in front of a group of pods. And it creates a cluster IP, which is a virtual IP, which is permanent, that can be routed to within the cluster. So let's look at how to define a service. If we cat service.yaml, we'll see a service definition. Again, we see a new type. So we've got v1 service. We've called this DevOps again, very creative with our names. And here we're seeing another example of using a selector. Every pod that has the label app DevOps is going to be pointed to by this service. So we're going to create an IP address that will be routing to all of these pods that are labeled this way. We have a port, so this is the port that we're going to address this service at. And then the target port is the port of the pod that we want to go to. So our pod is running on port 8080, and we want to eventually be curling on just port 80. One of the nice things here is that it selects based on the label, but the service doesn't own the pods. In fact, the deployment doesn't really own the pods either. Objects in Kubernetes are loosely coupled. So it means that you can have a bunch of pods running and put a service in front of them afterwards. Or you can move pods from one service to another service very easily. It kind of makes it a little bit more easy to do operational steps like that. So let's apply our service using kubectl apply-f service. And we see our service has been created. And if we run kubectl get services, then we see that there are 2 services in our cluster. There's one that we created called DevOps. There's a Kubernetes service, which is the Kube API server. And what we'll see is that we have a cluster IP now. And this is a virtual IP, which is in front of the 3 pods in our deployment. And it's running on port 80. So if we curl this, we get smooth DevOps. Great. So that's being routed to another pod. Cool. So that's an internal IP. That's a cluster IP. That's only addressable from within our service. So how do we get an address that we can hit from outside of our service? And there are a couple different ways that you can do that, and we're going to go over a couple right now. So the first one is with node ports. So you can add a type to your service and call it type node port. So here this is the exact same thing. We just added this type node port. And when we apply this, the service will pick a port, a large port number, like around 30,000 or something. And when you connect to any node in the cluster on that port, it will route us to our service, and we'll go to one of our pods. So if you're able to access one of our one of the nodes in the cluster externally. You just have to hit it at that port, and you'll be able to kind of expose your service externally in that way. So let's apply that. And then we can take a look at the services again. And we see now the type is node port. And here we see something a little bit different. We see it's assigned us this port, which is the node port. And if you click the plus button here, you can select a port to view on a different host. So I'm going to select a port to view on host 1. And I've just copied the port number. And when I say display that port, this is coming from outside of the cluster, and I'm hitting this port from outside the cluster, and I'm getting routed to my application, which is running inside of my cluster. Cool thing is all of my pods are running on the worker node, but I was able to hit the master node and get routed to my pods, which are running on the worker node. So you don't need to know where they're being run. It's kind of cool. Now, node ports are cool, but you might want to have a kind of proper load balancer. So you can, instead of doing type node port, you can do type load balancer. And in that case, Kubernetes will provision a cloud load balancer and point it to the pods. And this is useful. This is like kind of a more serious way of how you would publish your application externally. This wouldn't work in the sandbox because it won't be able to spin up a load balancer for us, but it's a useful thing to look into. So we've learned what Kubernetes is. We've kind of gone over some of the components that make up a Kubernetes cluster. We've deployed some of our first applications using kubectl, and we've looked at pods and a bunch of different kind of options that we can do for running pods. We've looked at deployments, and we've looked at services. And there's a lot more to learn. Like how do you deal with stateful services? Like if you want to have something more stateful. There's a lot of different resources. We have the pod and the deployment, but there are other things like stateful sets and volumes that you can do to deal with storage. If you want to do configuration, like by setting environment variables, or by passing secrets into your pods, then there are other resources called config maps and secrets. And if you want to have kind of a single run container, which is one task, then there are jobs and there are cron jobs. So there's a lot more to Kubernetes. It's a very powerful system, but I hope that that's given you a little bit of a taste. And if you do want to learn more, then I definitely recommend checking out kubernetes.io. There's a lot of kind of information on there that you can find. There are a couple of good books out there. Kubernetes Up and Running is a really nice book. The Kubernetes book is kind of a deep dive into Kubernetes. And that'll give you kind of a broader overview. And check out katacoda.com because there's a lot of other tutorials on katacoda.com to help you learn Kubernetes and other things. So I'm going to stick around at the end. If you have any questions, you can come up and ask me some questions. But apart from that, thank you very much.